Today's topic will be about CPU scheduling. Presented to you by Henry James Sabasaw. Let's begin the discussion by understanding what CPU scheduling is. CPU scheduling is a process which allows one process to use the CPU, while the execution of another process is on hold due to the unavailability of any resource, thereby making full use of the CPU. The aim of CPU scheduling is to make the system efficient, fast and fair. There are 5 scheduling algorithms. Number 1 is first come first serve scheduling or FCFS scheduling. Number 2 is shortest job first scheduling or SJF scheduling. Number 3 is priority scheduling. Number 4 is round robin scheduling or RR scheduling. And lastly, the multilevel queue scheduling. But for today's discussion, we will only focus on FCFS scheduling. So now, let us find out what first come first serve scheduling is. First come first served algorithm is the simplest scheduling algorithm. It is easy to understand and implement. Jobs are executed on first come, first serve basis. And its implementation is based on FIFO queue, or what we called the first in first out queue. Process that requests the CPU first is allocated the CPU first. It is used in batch systems. Its real-life analogy is just like buying tickets. Its implementation are FIFO queues. A new process enters the tail of the queue, and the schedule selects from the head of the queue. The performance metric of FCFS algorithm is the average waiting time. Its given parameters are burst time, which is in millisecond, the arrival time and order. Now let's proceed the discussion with this example. The first column contains the process, which are tasks that needs to be done or completed. Process 1 or P1 can be Google Chrome, P2 as Safari, P3 as Internet Explorer, P4 as Microsoft Office and P5 as iTunes. The second column is the burst time, which is the time needed for the completion of the process, and the last column contains the arrival time. The Gantt chart is used to test the FCFS algorithm. Let us now proceed to the FCFS scheduling example. The waiting time is the amount of time a process has been waiting in the ready queue, while the turnaround time is the total time taken between the submission of a process for execution and the return of the complete output to the user. Now here is the formula for computing the average waiting and turnaround time. To compute for the average waiting time, you need to get the sum of the waiting time for each process, then divide it to the total number of process. And just do the same computation for the average turnaround time. Our next topic will be about the problems that you may encounter with FCFS algorithm. It is non-preemptive, meaning if a process starts its execution, it will terminate only when it ends, while in preemptive a process can be interrupted by another process in its execution. With first come, first served, what comes first is handled first, the next request in line will be executed once the one before it is complete. It cannot utilize resources in parallel. Let's assume that one process CPU bounded and many IO bounded processes, resulting to a convoy effect, low CPU and IO device utilization. So you may ask, why convoy effect? The first reason is IO bound processes pass quickly through the ready queue and suspend themselves waiting for IO. Second is, the CPU-bound process arrives at head of queue and executes the program until completion. Third is, IO devices idle until the CPU-bound process completes. And lastly, a convoy effect happens when a set of processes need to use a resource for a short time, and one process holds the resource for a long time, blocking all of the other processes. Essentially, it causes poor utilization of the other resources in the system. And that's going to sum up our brief discussion about CPU scheduling, which focused on FCFS algorithm. Once again, Presented to you by Henry James Sabasa.